Hello, I'm Austin Murphy, and this is my research presentation on IMAPs and DNS. We'll start with IMAPs. As I kind of went over it last week, we will be using Dovecot as the application to implement IMAPs. And we went over POP3S last week, and so I will remind us all of the differences between them. So with the post office protocol, it downloads all your mail as you view it on your email client. It will delete it from the server, is what I'm trying to say. On IMAPs or IMAP, it syncs your email in the server with your client, like Outlook or Thunderbird. Dovecot is a secure IMAP POP3 server, so that's what we'll be using. I have yet to set it up, so I'm not very comfortable on it all yet. Postfix will be used to handle all of the sending and receiving of the mail, and Dovecot's what we connect to when we want to read the mail. Dovecot is the most standard IMAP server, and there's others like Courier, but a lot of people say they like Dovecot more. Let me go back 1 second. And this says most of Dovecot configuration will be configuring it to work with postfix to send the mail, and then for authentication, we'll configure it with a database like MariaDB, for example. And I mentioned it being a pop function, like on a stack, and whereas SMTPS is a push function. Everything I look up, it seems to say that POP3 is outdated, but there are some advantages to using POP3. You can view your email without an internet connection because it's downloaded directly to the client, and it can save storage space on the mail server. And I think I read somewhere that most of our ISPs will be using POP3, probably for that reason. IMAP is better um, because all the email is kept on the email server. It's synced to our devices so that we can access the email from our phone, our work computer, whereas POP3, it's downloaded to a single client and deleted. Synchronization is what I'm trying to say. And this says a disadvantage is that email is not viewable without an internet connection. Here, I just listed some hardening recommendations. I have yet to set it up on my server, so I can't offer you many details on the implementation. But here's a list of things we'll be looking through and a link of the resource. This does say the Dovecot was designed to be secure at the beginning, so it's pretty secure, but we'll still try to harden it. Moving on to my research on DNS for IIS and Bind application in Linux. It's called version 9 is the one I think we'll be using. When DNS was created, they did not have security in mind. So DNSSEC is something something that we focus on nowadays. We want to add privacy to our DNS. Request for comments 3833, RFC 3833. It outlines known threats to DNS, such as packet interception and name chaining. And it goes on to explain what we're looking for in DNS security. So it must be backwards compatible with insecure DNS, or it must coexist with insecure DNS. And we want it to uh, conceal our DNS for data integrity and data origin authentication. And this picture right here shows some keys being passed around. Keep in mind that all of those keys take more processing power. So looking at Bind9, I have some basic terms for DNS on this slide. Domain name server is how we translate and resolve host names into IP addresses. Humans are, it's kind of like a phone book where we look up a business by a name and we'll get a phone number. It's hard for humans to remember numbers. An increasing number of services depend on DNS, and so it's important for us to know how to do. And Bind is an open source software that enables us to publish our domain name system into the internet and resolve DNS queries for our users. It stands for Berkeley Internet Name Domain and was originally developed as part of the DARPA project, I believe. Here's some terms such as CNAME, which is like an alias, A record, etc. So I won't go over the history, but it said I learned from this that it is part of the DARPA project in the mid 80s. And in 2012, ownership was passed to ISC. It's been forked into Bind 10 was forked. ISC is still maintaining Bind 9. Bind 9 offers DNS security, so does IIS. And one way they do this is with transaction signature, NS update, IPv6, and a remote named daemon control with encryption via shared secret. TSIG transaction signature is going to use a lot of processing power and can sometimes make denial of service attacks even worse. But other than that, it's obviously good. Everybody's using it. So here's some basic installation for Bind9. I haven't done this yet, but these are my examples. I typed them in to one of my Ubuntu boxes. In this slide, we create a separate log file. By default, everything is logged into syslog, and a lot of things are logged into syslog. So this is how we can create a separate log file for Bind. System control restart Bind9 every time we make a change. We'll want to use that. Okay, so I'm editing the name.conf.options here, and we'll switch out that 192 with our own network. And the forwarders is kind of like backup DNSs. These are Google's 8888 and 8844. So we need to this we can copy and paste this into our Etsy bind name.conf options. Before we add our own domain names to the authoritated form, let's check that our DNS requests are going through bind. So we can open up a separate console, use tail tac f, which is it'll print to the console all new updates is what tac f is. And let's list our new bind.log. Now we can use dig or another application to make DNS requests, and it should be showing up in our new log file. All right, now we can add our domain names to the authoritative forum. To do that, we need to edit this file, etsy bind named.conf.local. And I mentioned this is how bad actors could potentially overwrite domains. I meant to switch that my domain name to something, but that's where you would put your domain name right there. And then we need to go in and configure our zone for that domain that we just listed in the name.conf.local file. So we will edit the start of authority, the SOA, and then we'll edit our name servers and map them out to IP addresses. And then let's test it with another dig DNS request. And this, to wrap it up, IIS is much simpler. We will go into Server Manager. For IIS, we'll add roles and features like we've done for the web server, and we'll check off DNS server and install it. We'll make sure that we'll go into our network configurations, and we'll edit our preferred DNS server to localhost so that it will point all our DNS traffic to our DNS server. And now we can bind addresses and add aliases and A names and all of that in DNS Manager. And there's still a lot left to the imagination here, as we have not set it up yet on the server. Here are some of my references I gained information from. All right, thanks for watching my video.